All right, market mechanics faithful, strap in. This week, we're diving into a geopolitical handshake that's either a stroke of genius or a deal made of wet sand. You pick. I'm talking about the recent sit-down between Donald Trump and Xi Jinping, their first in over 6 years. And folks, they struck a deal, a big one apparently, to delay export controls on rare earths and computer chips for a whole year. Trump himself, ever the modest diplomat, called the meeting a 12 out of 10. I mean, where do you even get a 12? Is that like a participation trophy for global diplomacy? But here's the kicker. While Trump sounded triumphant, many saw this as a win for China. Why? Because the U.S. essentially linked its high-tech export restrictions, think AI chips, to China's rare earth exports. Plus, with fentanyl tariffs halved, the average tariff rate on Chinese goods drops to a mere 31%, making production in China a bit more attractive. Markets breathed a sigh of relief, but economists, they're calling this agreement sketchy, temporary, and built on sand. So what does that even mean? And what are these rare earths that are causing such a ruckus? Let's dig in. Rare earth elements. Sounds like something out of a sci-fi movie, right? Turns out they're the unsung heroes of our modern world. These 17 metallic elements, crucial components in practically everything you touch: your smartphone, electric motors and EVs, airplanes, fiber optic networks, medical imaging equipment, even missile guidance systems and jet engines. If you can learn to spell all their names, you'll have a real edge in Scrabble, trust me. Now, despite the name, they're not actually that rare. It's not like finding a unicorn. The problem is they're found together in low concentrations, making mining and separating them a complex, expensive, and frankly messy process. Refining them is energy-intensive and often involves strong acids. It's not exactly a pretty picture. And that, my friends, is partially why China dominates the industry. While other countries were busy humming kumbaya and worrying about environmental costs, China spent decades building the infrastructure, accepting the trade-offs, and scaling up production. Demand for these elements has exploded over the last 25 years, growing just as fast as production. Take neodymium magnets, for example. Small, powerful, efficient. Essential for miniaturizing components, reducing energy consumption. Try building a drone without them, I dare you. They're also critical for fiber optic cables, the backbone of our internet. Different rare earths dope the glass fibers, allowing light signals to travel continents without degradation. Without them, your cat videos wouldn't stream in HD, and global finance would grind to a halt. While military applications get all the hype when supply chains get tight, the vast majority of demand comes from civilian industries: electronics, cars, energy, telecom. Harvard points out that electric cars require 6 times the mineral inputs of conventional cars, and wind plants need 9 times more minerals than gas-fired plants. So, while they do have military uses, the real demand is powering your everyday life. So, how did we get here? Well, from the 1960s through the 1980s, the United States was actually the dominant global producer of rare earth elements, largely thanks to the Mountain Pass mine in California. But in 2002, after a toxic waste spill and radioactive wastewater leaking into the desert, the mine shut down. It just wasn't viable anymore, thanks to cheaper Chinese imports, soaring environmental compliance costs, and, well, pollution issues. The site saw a brief revival, went bankrupt, and was eventually taken over by financiers who founded MP Materials in 2017. Flash forward to earlier this year. The U.S. government acquired a 15% stake in the company for $400 million, part of a broader public-private partnership aimed at building a domestic supply chain for rare earth magnets. Even Apple has committed $500 million in a long-term partnership to source American-made rare earth magnets. Build a recycling facility right there at Mountain Pass. But here's the rub. Starting in the 1990s, a perfect storm of environmental regulations, corporate short-termism, and outsourcing led to a steep decline in U.S. rare earth production. China, meanwhile, played the long game. They strategically invested in the industry, offering lower costs and, shall we say, fewer environmental constraints. By the early 2000s, China had overtaken the U.S., and today they supply around 80% of the world's rare earths and handle over 90% of the refining. They also manufacture nearly all the magnets that use these materials. In China, the entire supply chain, from ore to finished components, is vertically integrated and geographically concentrated. Now here's a fun fact. China's dominance in this sector is arguably more strategic than economic. Selling rare earths isn't hugely profitable. The U.S. spends more than 20 times as much on avocado imports each year as it does on rare earths. The difference, of course, is that no one ever threatened to cut off the guacamole supply. Because rare earths are so deeply embedded in nearly every advanced industry, controlling their flow means influence over production timelines, pricing, and provides huge geopolitical leverage when needed. It's not about the money, it's about the power. China's geopolitical edge in controlling this small but vital industry comes from its ability to cause massive disruptions. When export licenses are delayed or denied, supply chains around the world can simply grind to a halt. Remember, these elements aren't rare, but the ability to refine and produce them at scale is. China built that capacity through decades of industrial investment, a tolerance for environmental costs, and technical process development. The whole process is messy, expensive, and incredibly difficult to scale up quickly, especially under Western environmental and regulatory constraints. Environmental approvals in Western countries can take years. Labor costs are significantly higher, and expertise in this niche field is extremely limited. Most of the engineers with experience retired years ago. So even with government backing and corporate investment, progress has been slow. Now, China's export licensing system has become a central tool in its trade strategy. Since 2023, Beijing has expanded the scope of these licenses to cover over 700 different products, including rare earths, manufacturing equipment, and other critical inputs. These licenses are typically issued for 6 months and require detailed disclosures about the buyer, the intended use, and the final product. In some cases, exporters are even asked to collect technical documentation or proprietary information from their customers as part of the application process. This system gives Beijing a golden window into foreign supply chains. They can track demand patterns, identify potential stockpiling, and monitor for buyers who might be reselling materials. It also allows for selective enforcement on a customer-by-customer basis. Licenses can be quietly delayed or withheld, creating uncertainty without the diplomatic cost of a formal ban. We've seen reports that German firms have received more approvals than their American counterparts, while Indian buyers have faced even longer delays. This licensing regime mirrors the U.S. Foreign Direct Product Rule, which extends U.S. restrictions to items made abroad if they use American technology. Beijing has adopted this logic, applying restrictions to goods produced outside of China if they rely on Chinese inputs or know-how. If the U.S. were cut off by China, other nations might hesitate to re-export to American buyers. Not just to protect their own access, but also because recent U.S. trade aggression has strained relationships with the rest of the world. In a moment of scarcity, Washington might find fewer of its historical allies willing to take big economic risks on its behalf. Heavy rare earths, in particular, have received special attention from the Chinese government. These elements are super valuable and incredibly difficult to substitute thanks to their unique properties, like enhancing thermal stability in powerful magnets, essential for defense, space, and energy tech. China has even banned the export of rare earth processing technology. And get this, according to reports from the Wall Street Journal and Reuters, China's Ministry of Commerce began requiring rare earth firms to register technical staff and collect their passports, effectively limiting their ability to travel abroad, even for personal holidays. The goal? To prevent leaks of sensitive technical knowledge and maintain China's strategic advantage. This opaque licensing regime is by design, giving China the ability to exert pressure without ever having to issue a formal embargo. Snaky, right? China's use of rare earths as a trade weapon is actually nothing new. Back in 2010, during a maritime dispute with Japan, Beijing quietly cut off rare earth exports to Japanese manufacturers. The move caused immediate disruption. Japanese firms, caught completely off guard, were forced to halt production lines. The Japanese government caved, releasing the Chinese fishermen that had been arrested, and China resumed shipments shortly after. That episode left a lasting impression. Japan, up until that point, had relied on just-in-time manufacturing, which basically means they didn't keep huge stockpiles. After 2010, they started stockpiling rare earths, investing in alternative sources, and redesigning products to reduce reliance on Chinese materials. According to The Economist, Japan's dependence on Chinese rare earths has fallen from 90% in 2010 to around 60% today. Japanese auto manufacturers even developed electric motors for their hybrid cars that didn't require rare earth magnets. The 2010 embargo also triggered a formal complaint at the World Trade Organization. The US, the EU, and Japan jointly challenged China's export restrictions. In 2014, the WTO ruled against China, stating its policies violated international trade rules. Beijing agreed to remove all quotas, but by then, the message had been delivered loud and clear. China was willing to use its control of rare earths as a geopolitical tool. This isn't some new revelation. In 1987, China's former leader Deng Xiaoping famously said, and I quote, "While the Middle East has oil, China has rare earths," foreshadowing China's willingness to use its leverage. Fast forward to 2019, a week after the Trump administration blacklisted Huawei, Xi Jinping toured a rare earth processor in China and highlighted the importance of rare earths in global supply chains. This was widely interpreted as a direct threat to restrict Chinese exports to the US. Chinese state media followed with editorials warning that China could cut off supplies if pushed too far. One headline read, "Don't say we didn't warn you." In Chinese political discourse, rare earths are often described as both a strategic resource and a national treasure. The Financial Times has reported that Beijing views rare earths as both a sword and a shield, a means of defense and a tool of coercion. The term assassin's mace has also appeared in official rhetoric, referring to asymmetric trade capabilities designed to counter more technologically advanced adversaries. These signals aren't just for foreign audiences. They serve a domestic purpose too. The trade war has allowed Xi to frame China's economic challenges as the result of foreign hostility. This narrative has helped consolidate political support at home, even as the country grapples with deflation, a property crisis, and slowing growth. Rare earths, in this context, are more than a bargaining chip. They're a symbol of national strength and a reminder that China is prepared to fight on its own terms. The rare earth standoff may have started as a dispute between the United States and China, but its effects have rippled far beyond Washington and Beijing. Europe, India, Japan, and other manufacturing economies have found themselves caught in the crossfire. Take early October, for example. The Dutch government took temporary control of a Chinese-owned chipmaker based in the Netherlands called Nexperia, citing governance concerns and national security risks. The CEO was accused of misappropriating over $200 million of company funds to benefit another company he owned in China. Dutch officials were concerned that the company's operations and intellectual property were being shifted to China. Why does this matter? Nexperia's chips are widely used across Europe's industrial base, in cars, medical devices, and defense systems. According to local reports, 49% of European auto companies, 86% of medical device firms, and the entire European mechanical engineering and defense sectors rely on Nexperia's components. Since the dispute began, the company has reportedly struggled to secure rare earth supplies from China, and the resulting shortages have started to affect production. China's control over rare earths is just one part of its broader trade strategy. Over the past year, Beijing has been quietly stockpiling industrial inputs, including oil, natural gas, iron ore, bauxite, and copper. According to The Economist, these purchases accelerated in early 2024 in anticipation of a possible Trump victory. Even as China's industrial output slowed, metal imports surged. The goal appears to be strategic insulation, to ensure that in the event of renewed trade hostilities, China can continue to operate without relying too much on foreign suppliers. This stockpiling strategy has costs, of course. Large purchases drive up prices and tie up capital, but Beijing seems willing to absorb these costs in exchange for greater resilience. At the same time, China has been diversifying its sources of supply, buying oil and gas from Russia, investing in African mining projects, and building out domestic refining capacity. Now, China's economy has been under strain for quite some time. The property market is in a deep, prolonged slump, now entering its fifth year. Deflation has taken hold, with falling prices reflecting weak consumer demand and overcapacity in key sectors. Youth unemployment remains high, and business confidence has been dented by regulatory crackdowns and sluggish domestic spending. But despite these pressures, the confrontation with the United States has actually strengthened Xi Jinping's position at home. The trade war has provided a convenient external enemy. The narrative of foreign encirclement has allowed the Communist Party to rally public support and to justify tighter political control. It's also reinforced Beijing's push for self-sufficiency, expanded industrial policy, and accelerated efforts to reduce reliance on foreign technology and materials. And China's confidence isn't entirely unfounded either. Its exports have remained strong despite U.S. tariffs. Its stock market has outperformed U.S. indices in dollar-adjusted terms, and its domestic tech sector has made visible progress, including the recent DeepSeek AI breakthrough. Remember Trump's stocks in Malaysia, Japan, and South Korea over the first 4 days of his Asia trip, an exercise in flattering the American president. South Korea gifted him a golden crown and a medal. Japan's prime minister gave him a golden golf ball and told him she had recommended him for a Nobel Prize. His meeting with Xi, however, was described by the BBC as a meeting of equals on a global stage where the stakes for both nations were enormous. Xi felt no need to flatter Trump with gifts, military bands, or honor guards. Beijing appears to believe it can weather the trade war with the United States. And whether that confidence is justified or not remains to be seen. China's control over rare earths does give it leverage, but not without limits. The global response to its export restrictions has already begun to erode the foundations of that dominance. Japan's experience after the 2010 embargo is incredibly instructive. Caught off guard by the sudden cutoff, Japanese manufacturers rushed to redesign products to reduce their reliance on rare earths. The government invested in alternative sources and built up strategic reserves. Over time, Japan's dependence on Chinese rare earths declined. The lesson was clear. Supply shocks create incentives to adapt. That pattern is now repeating across Europe, North America, and parts of Asia. Companies are exploring ways to reduce their exposure. Some are turning to recycling. Others are redesigning electric motors to use fewer rare earths or, get this, none at all. BMW and Renault, for example, have developed electric vehicles that rely on externally excited motors rather than permanent magnet designs. These motors are larger and more complex, but they completely avoid the need for rare earth magnets. German auto parts manufacturer ZF Group has developed a magnet-free motor that matches the size and performance of traditional EV designs, and several automakers are now exploring its use. Startups are also experimenting with new materials. Tetranite, a rare iron-nickel alloy once found only in meteorites, can now be synthesized in the lab. A US-based firm is developing magnets made from iron and nitrogen, both abundant and inexpensive. These technologies are still experimental, but they point to a future where rare earths are no longer the only option. Javier Blas, writing for Bloomberg, has even argued that the rare earths panic is totally overblown. He points out that the total value of U.S. imports of rare earths from China is relatively small, around $170 million a year, and the quantities used in military applications are minimal. Blas argues that most rare earths go into consumer products like vacuum cleaners, smartphones, and electric vehicles. If prices rise, manufacturers will just have to adapt. As the saying goes, high prices are the best cure for high prices. China's dominance in this space is real, but it's not unassailable. The more aggressively China uses rare earths as a weapon, the more it encourages others to find alternatives. The global response to China's rare earths dominance has already moved beyond rhetoric. Governments and companies are now investing in alternatives, not just to diversify supply, but to reduce dependence altogether. Recycling is possibly the most promising solution. While rare earths aren't widely recycled today, that's beginning to change. In France, a facility is being built to process around 2,000 tons of magnets a year using scrap from electric motors and manufacturing waste. In Canada, a company is developing plants to recover rare earths from e-bikes, hard drives, and other discarded electronics. Apple, as I mentioned earlier, has announced a partnership with MP Materials to support rare earth recycling at Mountain Pass. These efforts are still small in scale, but they represent a crucial shift in mindset from linear supply chains to circular ones. Governments are also rethinking their approach to supply chain security. Japan, as I mentioned, has built up strategic reserves and diversified its suppliers. In Frankfurt, a World War II-era bunker now houses 300 tons of rare earths stored by a private metals merchant. Some of the material stored there is owned by manufacturers, but much of it is held by intermediaries who anticipate rising prices. Future shortages. The Pentagon's investment in MP Materials is part of a broader U.S. effort to rebuild domestic manufacturing, but so far, progress has been slow. The just-in-time model that defined global manufacturing for decades is now being reassessed. Companies are beginning to prioritize resilience over efficiency. That means holding more inventory, building redundant supply chains, and investing in technologies that reduce exposure to geopolitical risk. Rare earths are now a strategic variable, and the world is adjusting accordingly. So, this announced agreement between Trump and Xi appears to have paused the immediate crisis, but let's be clear, it hasn't resolved the underlying conflict. Rare earths remain a pressure point, a tool that China can deploy again with little warning. The agreed deal is explicitly temporary, with key provisions set to expire in a year. None of the 5 prior meetings between Trump and Xi have produced a lasting deal, and there's little reason to believe this one will be any different. Trump has already suggested it could be renegotiated annually, raising the prospect of a permanent state of trade uncertainty. The strategic logic behind China's rare earths policy is quite obvious. For a relatively small loss in export revenue, Beijing can inflict significant disruption on foreign industries. These materials are embedded in everything from smartphones to satellites. Restricting their flow doesn't just raise prices, it halts production, exposes vulnerabilities, and forces uncomfortable political choices. But this strategy carries big risks. The more China uses rare earths as leverage, the more it encourages others to adapt. Substitution, recycling, and stockpiling are no longer theoretical responses. They're active areas of investment. Japan has already reduced its dependence. Europe and the United States are following suit. If China is to think of rare earths as its assassin's mace, it has to be careful how it uses them. It's quite a balancing act for China, because if they play this hand too often, it stops working, and a small reduction in dominance in this sector could reduce its negotiating power disproportionately. The deeper structural issues remain unresolved. China's industrial policy, its push for technological self-reliance, and its use of trade as a geopolitical instrument are still in place. The United States, for its part, continues to wield tariffs and export controls with little predictability. The current truce might hold for a few months, but the overall relationship remains fragile, and the next disruption is only ever one political decision away. The information provided in this video is for general informational purposes only and does not constitute financial, investment, or legal advice. Please consult with a qualified professional for personalized advice. Market Mechanics is not responsible for any actions taken based on the information presented herein.